Hello, my name is Shrish, and for this year's Science and Engineering Fair, I built a robot with autonomous functionality that can stack shoes into shoe racks. Let me start off with a tour of the current robot. There are mechanical and structural components like the chassis, wheels, motors, and servos. The brains of this robot consist of a Raspberry Pi microcontroller, RoboClaw motor controller, and a servo hat. The robot also has a Logitech web camera to act as its eyes during autonomous drive. This camera also collected data that trained my machine learning models. Finally, the robot uses a 12-volt battery and Anker power bank as its energy sources. This robot that you see here now is not the first prototype I built. It took a few iterations and several rounds of testing and fine-tuning to arrive at this current version of my prototype. As for the coding, I first coded the robot for RC Drive. This code was written in Python and it is event-based. After I tested my physical iterations with RC Control, I also added features to capture and save images while driving the robot. I used these images to train my machine learning models with Edge Impulse. Edge Impulse allowed me to quickly train and modify my models in a short amount of time, but it had its limitations on the size of the models that can be trained for free. In the end, I was able to build a robot that can stack shoes. Now, let us see a demo of the Shoe Stacker Bot in RC Control. RC Control has a success rate of 100%. This is because a human is controlling the robot and can think of solutions for real-world edge cases like multiple pairs of shoes, flipped over shoes, and more. Even though using this robot in RC Control is very fun, the goal of this project was to make an autonomous shoe stacking robot, which we will see a demo of now. The autonomous functionality of this robot had a success rate of 78% on end-to-end autonomous drive in a controlled setting. The monitor in the back of this demo is not required for the robot to run and is just there to show you what the robot is seeing through its Logitech camera. There are 3 models that make up my autonomous functionality. One model identifies the shoe, places a bounding box around the shoe, and moves towards the shoe. My second model rotates around the shoe to get into the correct grip position. My final model identifies and moves towards the shoe rack with the shoe for stacking. To conclude, day-to-day chores like stacking shoes and shoe racks are necessary to maintain our quality of life, yet they are redundant and monotonous. I strongly believe that it is important to automate menial and dull tasks like these to better our lives and help us focus on things that matter more to us. This engineering project is a huge success towards demonstrating the possibilities of automating menial household tasks. The result of this project has supercharged my enthusiasm to further explore possibilities of applying AI and robotics to help humans. Thank you.